Artificial life is a field of study and an associated art form which examines systems related to life, its processes, and its evolution. Through the use of simulations with computer models, robotics, and biochemistry. The discipline was named by Christopher Langton, an American computer scientist, in 1986. There are three main kinds of ALife, named for their approaches. Soft from software, hard from hardware, and wet from biochemistry. Artificial life imitates traditional biology by trying to recreate some aspects of biological phenomena. Overview. Artificial life studies the logic of living systems in artificial environments in order to gain a deeper understanding of the complex information processing that defines such systems. Also sometimes included in the umbrella term, artificial life, are agent-based systems which are used to study the emergent properties of societies, of agents. While life is, by definition, alive, artificial life is generally referred to as being confined to a digital environment and existence. Philosophy. The modeling philosophy of all life strongly differs from traditional modeling by studying not only life as we know it, but also life as it might be. A traditional model of a biological system will focus on capturing its most important parameters. In contrast, an ALife modeling approach will generally seek to decipher the most simple and general principles underlying life and implement them in a simulation. The simulation then offers the possibility to analyze new and different lifelike systems. Vladimir Georgievich Rydko proposed to generalize this distinction to the modeling of any process, leading to the more general distinction of processes as we know them, and processes as they could be, at present. The commonly accepted definition of life does not consider any current ALife simulations or software to be alive, and they do not constitute part of the evolutionary process of any ecosystem. However, different opinions about artificial life's potential have arisen. The strong ALife position states that life is a process which can be abstracted away from any particular medium. Notably, Tom Ray declared that his program Tierra is not simulating life in a computer, but synthesizing it. The weaker life position denies the possibility of generating a living process outside of a chemical solution. Its researchers try instead to simulate life processes to understand the underlying mechanics of biological phenomena. Organizations. Software-based soft techniques. Cellular automata were used in the early days of artificial life, and are still often used for ease of scalability and parallelization. ALife and cellular automata share a closely tied history. Neural networks are sometimes used to model the brain of an agent. Although traditionally more of an artificial intelligence technique, neural nets can be important for simulating population dynamics of organisms that can learn. The symbiosis between learning and evolution is central to theories about the development of instincts in organisms with higher neurological complexity, as in, for instance, the Baldwin effect. Notable simulators. This is a list of artificial life, digital organism simulators, organized by the method of creature definition. Program-based simulations contain organisms with a complex DNA language, usually Turing-complete. This language is more often in the form of a computer program than actual biological DNA. Assembly derivatives are the most common languages used. An organism lives when its code is executed, and there are usually various methods allowing self-replication. Mutations are generally implemented as random changes to the code. Use of cellular automata is common but not required. Another example could be an artificial intelligence and multi-agent system program. Module-based individual modules are added to a creature. These modules modify the creature's behaviors and characteristics either directly, by hard coding into the simulation, or indirectly, through the emergent interactions between a creature's modules. Generally these are simulators which emphasize user creation and accessibility over mutation and evolution. Parameter-based organisms are generally constructed with predefined and fixed behaviors that are controlled by various parameters that mutate. That is, each organism contains a collection of numbers or other finite parameters. Each parameter controls one or several aspects of an organism in a well-defined way. Neural net-based, these simulations have creatures that learn and grow using neural nets or a close derivative. Emphasis is often, although not always, more on learning than on natural selection. Hardware-based artificial life mainly consists of robots, that is, automatically guided machines able to do tasks on their own. Biochemical-based life is studied in the field of synthetic biology. It involves e.g., the creation of synthetic DNA. The term wet is an extension of the term wetware. Open problems in ALife. How does life arise from the non-living? Generate a molecular proto-organism in vitro. Achieve the transition to life in an artificial chemistry in silico. Determine whether fundamentally novel living organizations can exist. Simulate a unicellular organism over its entire life cycle. Explain how rules and symbols are generated from physical dynamics in living systems. What are the potentials and limits of living systems? Determine what is inevitable in the open-ended evolution of life. Determine minimal conditions for evolutionary transitions from specific to generic response systems. Create a formal framework for synthesizing dynamical hierarchies at all scales. Determine the predictability of evolutionary consequences of manipulating organisms and ecosystems. Develop a theory of information processing, information flow, and information generation for evolving systems. How is life related to mind, machines, and culture? Demonstrate the emergence of intelligence and mind in an artificial living system. Evaluate the influence of machines on the next major evolutionary transition of life. Provide a quantitative model of the interplay between cultural and biological evolution. Establish ethical principles for artificial life. Related subjects. Artificial intelligence has traditionally used a top-down approach, while ALife generally works from the bottom up. Artificial chemistry started as a method within the ALife community to abstract the processes of chemical reactions. Evolutionary algorithms are a practical application of the weak ALife principle applied to optimization problems. Many optimization algorithms have been crafted which borrow from more closely mirror ALife techniques. The primary difference lies in explicitly defining the fitness of an agent by its ability to solve a problem, instead of its ability to find food, reproduce, or avoid death. The following is a list of evolutionary algorithms closely related to and used in ALife. Ant colony optimization, bacterial colony optimization, genetic algorithm, genetic programming, swarm intelligence. Multi-agent system. A multi-agent system is a computerized system composed of multiple interacting intelligent agents within an environment. Evolutionary art uses techniques and methods from artificial life to create new forms of art. Evolutionary music uses similar techniques, but applied to music instead of visual art. Abiogenesis and the origin of life sometimes employ life methodologies as well. History. Criticism. ALife has had a controversial history. John Maynard Smith criticized certain artificial life work in 1994 as fact-free science.